Hello, and welcome to a lab reviewing fundamental operations in intermediate algebra. In this lab, we're going to look at three main mathematical concepts that will be fundamental for your success in the remainder of this course. The first objective will be to perform addition and subtraction of fractions. The second objective will be to simplify numerical expressions using the order of operations. And our third objective will be to evaluate algebraic expressions. As we go along, please print the outline and complete it as you watch the video. Feel free to pause or rewind as needed. Okay, let's look at addition and subtraction of fractions. First, to add or subtract fractions, we must have like denominators. In order to do that, sometimes it's necessary for us to find a common denominator. The common denominator is the least common multiple of the denominators. That is, this is the smallest number that is a multiple of all denominators. Okay, in order to add or subtract fractions, we first have to find the common denominator between all fractions, convert each fraction to an equivalent fraction with the common denominator, add or subtract the numerators, and then simplify. Let's quickly review the concept of finding a least common multiple. Pretend that 8 and 10 are denominators. Let's find the least common multiple between 8 and 10. One approach to finding the least common multiple is to check multiples of the larger number. In this case, the larger number is 10. So we first check 10. Is 10 a multiple of both numbers? 10 is a multiple of itself, but 10 is not a multiple of 8. So let's check the next multiple of 10. That would be 20. 20 is also not a multiple of 8, so we have to go to the next multiple of 10, which will be 30. 30, again, not a multiple of 8, because it will not divide 8 evenly. The next multiple of 10 will be 40. 40 is a multiple of 8. 40 will divide 8 evenly. So therefore, 40 would be our least common multiple between 8 and 10. Okay, let's look at a problem. You're in the process of making your famous gumbo. The recipe calls for 5/8 of a teaspoon of cayenne pepper. You've always thought this was a little too much and want to reduce the amount of cayenne pepper by 1/4 of a teaspoon. How much cayenne pepper do you need for your gumbo? Well, this problem calls us for us to subtract two fractions. We'll need to take the original amount of cayenne pepper, 5/8, and subtract 1/4 of a teaspoon. In order to subtract 5/8 minus 1/4, we'll need to find a common denominator. So in this case, we're looking for the least common multiple between 8 and 4. The least common multiple between 8 and 4 would be 8, because 8 will divide 4 evenly. So therefore, we'll rewrite each fraction with an equivalent fraction of our least common denominator. 5/8 doesn't need to change because it already has a denominator of 8. 1/4 we'll need to convert to an equivalent fraction. 4 times what will give us 8? Well, 4 times 2 will give us 8. But if I multiply by 2 in the denominator, I'll also need to multiply by 2 in the numerator. So 4 times 2 is 8, and 1 times 2 is 2. So our numerator is 2. Notice that 2/8 is the same as 1/4. All we did was convert to an equivalent fraction. So now we can add or subtract the numerators and simplify. 5 minus 2 is 3. Our common denominator is 8. 3/8 cannot be simplified any further. So therefore, how much cayenne pepper do you need for your gumbo? We now need 3/8 of a teaspoon. All right, let's practice another problem. Work this one with me. Negative 5/6 minus 1/9. So in order to subtract these two fractions, we'll need a common denominator. What would our least common denominator be? Well, let's check 9. 9 is not a multiple of 6, so we'll have to check the next multiple of 9. Next multiple of 9 is 18. 18 is a multiple of 9 and a multiple of 6, so therefore 18 would be our least common denominator. So I'm going to rewrite each fraction with the least common denominator of 18. Now we're going to need to convert each fraction to an equivalent fraction with that least common denominator. So first let's work on negative 5/6. 6 times what will give me 18? Well, 6 times 3 will give me 18. But if I multiply by 3 in the denominator, I would have to multiply by 3 in the numerator. Remember, 3 over 3 is really just 1. All we're doing is converting to an equivalent fraction with a different denominator. Negative 5 times 3 would be negative 15. And let's do the same thing to 1 over 9. So converting to an equivalent fraction, we would need to multiply by 2 over 2. 9 times 2 is 18. 1 times 2 is 2. And now we can simplify. So let's see what the result is. We know our denominator. Our common denominator is 18. By combining the numerators, negative 15 minus 2 will give us negative 17. Negative 17 over 18 cannot be reduced any further, so therefore our result would be negative 17 over 18. Okay, let's move on to the next objective. Our next objective is to simplify numerical expressions using the order of operations. Let's review a few concepts before we begin. Remember, the ability to simplify numerical expressions is a very important skill, which you'll use throughout the remainder of this course. The rules for the order of operations are these. First, before we do anything else in an order of operations problem, we're going to take care of any grouped parts first and work inside out. So if there are any sets of parentheses in your problem or any sets of brackets in your problem, then we want to take care of what's ever inside of those first and work your way out. So start with the most innermost and work your way out. Do any exponentiation, roots, or absolute value next. So therefore, if you have something raised to a power, like 3 squared, or a root, such as the square root of 9, or an absolute value, maybe something like the absolute value of negative 2, then we would want to take care of that next in our order of operations. Third in the order of operations is to take care of any multiplication or division. Multiplication and division has the same power in the order of operations. So we're going to do it in order that it comes from left to right. And then last, we'll do any addition or subtraction. Also in order from left to right. So let's try a problem. Work along with me. Our goal is to simplify 6 minus 1/2 times 8 minus 5 times 3/10. In this problem, notice that there is multiplication and subtraction. So what's the first thing that we need to take care of? Very good. We'll need to take care of the multiplication. So let's multiply 1/2 times 8. 1/2 times 8 would be the same as 1/2 times 8 over 1. And we're going to multiply the top times the top and the bottom times the bottom. We can reduce any common factors. 2 and 8 have a common factor of 2, which would give us 4 in the numerator. 1 times 4 is 4 over 1, so that would give us 4. Rewrite on the next line. So that would be 6 minus 4 minus, and now let's take care of our next multiplication. 5 times 3 over 10. Well, 5 is the same as 5 over 1, multiplied by 3/10. So we're going to multiply the top times the top and the bottom times the bottom. We are allowed to reduce any common factors. So in this problem, we have a common factor of 5. So we can reduce that. That would leave us with 1 in the numerator and 2 in the denominator. So therefore, 1 times 3 is 3, and 1 times 2 is 2. Okay, moving right along. Next, we have subtraction, so we're going to work in order from left to right. If we work in order from left to right, 6 minus 4 is 2, minus 3 halves. So in order to subtract 2 minus 3 halves, what do we have to do? That's correct, we need to find a common denominator. So in this case, 2 is like 2 over 1. So the common denominator between 1 and 2, of course, would be 2. So therefore, we're going to rewrite each fraction with the common denominator, convert each to an equivalent fraction. So 2 over 1, we would have to multiply by 2 in the bottom and the top, which would be equivalent to 4 over 2. And 3 over 2 will remain the same because it already has a denominator of 2. We add or subtract the numerators and keep the same denominator. 4 minus 3 is 1 over 2. So this problem reduces to 1/2. All right, let's try another. Work this along with me. Our job is to simplify 4 times the absolute value of 6 minus 8 minus 56 divided by 7. In this problem, notice we have absolute value, we have subtraction, and we have division, and also multiplication. So the first thing that we need to take care of is the absolute value. Notice that 6 minus 8 is inside the absolute value bar. 6 minus 8 is negative 2. So that would give us 4 times the absolute value of negative 2 minus 56 divided by 7. All right, taking care of the absolute value of negative 2, remember, absolute value is the distance from 0 on a number line. So the absolute value of negative 2 is 2. That would be 4 times 2 minus 56 divided by 7. So now we have multiplication, division, and subtraction. The next step would be to take care of the multiplication and division in order from left to right. So 4 times 2 is 8, minus 56 divided by 7, which is 8. So our last step is to subtract 8 minus 8. 8 minus 8 is 0. So therefore, this problem simplifies to 0. Okay, very good. Let's look at another problem. In this order of operations problem, we have a numerator and a denominator. When you have a numerator and a denominator, we want to clean up all of the numerator and then clean up all of the denominator, and then we can divide the two. So our first job is to clean up the numerator. Notice in the numerator, we have negative 6 plus the square root of 81 in parentheses times negative 3 squared. So let's take care of our root first inside the grouping symbol. That would give us negative 6 plus the square root of 81, which is 9, and negative 3 squared. Remember, in this case, 3 is our base. 3 squared is 9, so that negative is still out in front, and that would give us negative 9. All divided by negative 3 minus 6. Okay, so let's clean up each grouping symbol in the numerator. Negative 6 plus 9 would give us a positive 3. times a negative 9, all divided by negative 3 minus 6. Notice we haven't done anything to the denominator yet. We're just cleaning up the numerator. All right, so positive 3 times a negative 9 would give us negative 27 divided by negative 3 minus 6, which would be negative 9. Negative 27 divided by negative 9 would give us a positive 3. So this problem simplifies to positive 3. All right, very good. Let's move on to our third objective. The last objective in this lab is to evaluate algebraic expressions. Remember, many problem-solving situations require the need to evaluate algebraic expressions. You will use this throughout the remainder of this course. A variable is a symbol, such as a letter, many times X, but not always, used to represent the members of a particular set. An algebraic expression is any meaningful combination of numbers and variables resulting from mathematical operations. So here's an example of an algebraic expression. X to the fourth power minus 3x plus x times y squared. Our job is to clean up this algebraic expression given certain values for x and y. In this case, we're given that x is negative 3 and y is negative 2. So our job is to substitute for that x and y variable and then simplify what is left. So let's plug in. First of all, let's plug in for x. We know that x is negative 3. X to the fourth power would give us negative 3 raised to the fourth power minus 3 times negative 3 plus negative 3 times y squared. Remember, y is negative 2. So negative 2 squared. All we've done is simply plug in for the x and y variable. Our next step is to simplify the resulting order of operations problem. So we can see in this problem we have exponentiation, we have multiplication, subtraction, and addition. So let's take care of the exponentiation first. Negative 3 to the fourth power. Notice negative 3 is in parentheses, so therefore negative 3 is our base. So this would be like negative 3 times negative 3 times negative 3 times negative 3. That would give us a positive 81 minus 3 times negative 3 plus negative 3 times negative 2 squared. So let's take care of that exponentiation. Again, negative 2 is in parentheses. So negative 2 is our base. Negative 2 squared would be a positive 4. Okay, so our next step is to clean up what's left. Notice there's multiplication, subtraction, and addition. So our next job will be to take care of any multiplication. So we have 81. Negative 3 minus 3 times 3 would give us a positive 9. Negative 3 times 4 would give us a negative 12. So plus a negative 12, or we could write that as minus 12. So the result is 81 plus 9 minus 12. We have addition and subtraction, so we're going to do it in order from left to right. 81 plus 9 would be 90. 90 minus 12 would give us 78. Okay, very good. All right, now here we have another algebraic expression that we need to simplify. In this case, we have a numerator and denominator. How many variables do we see? That's right, 3 variables. So our variables are x, y, and z. We're given that x is -2, y is 4, and z is equal to -6. So let's simplify. Our first step is to plug in for x, y, and z. So in the numerator, we have 3 times x, which is -2, plus 2 times y. Y is 4, all divided by 2 times z. Z, in this case, is -6 minus 1. All right, so now what we're left with is an order of operations problem. So let's clean up the numerator and denominator separately and then simplify. In the numerator, we have -3 times 2 plus 2 times 4. So let's take care of the multiplication first. 3 times -2 is -6, plus 2 times 4, which is 8, all divided by 2 times -6, which would give us -12, minus 1. All right, so cleaning up numerator and denominator separately, -6 plus 8 is +2. In the denominator, -12 minus 1 would give us a -13. So 2 over -13 cannot be reduced any further, so this would be our remaining result. And we've simplified that algebraic expression. Let's look at one last problem simplifying an algebraic expression. In this case, we have an absolute value expression where we have 3 variables, x, y, and z. In this case, we're given that x is -1, y is equal to 5, and z is equal to 2. So plugging in for each of our variables, we have negative times the absolute value of z, z is equal to 2, minus x, x is equal to -1, close absolute value, plus 5 times the absolute value of y, y is -5. Okay, once we've carefully plugged in for each of our variables, we just have to clean up the resulting order of operations problem. Notice we have absolute value, we have multiplication, we have subtraction, and addition. So what's first? That's correct. We need to take care of anything inside the absolute value. So our negative, it stays out in front, and let's clean up inside the absolute value. We have 2 minus a -1, which is the same as 2 plus 1, so this would give us the absolute value of 3, plus 5 times the absolute value of -5. All right, taking care of those absolute values, remember, absolute value is the distance from 0 on a number line. So the absolute value of 3 is 3. Our negative is still out in front, plus 5 times the absolute value of -5. The absolute value of -5 is, that's correct, 5. So our remaining operations are multiplication, addition, and addition. So we need to take care of multiplication first. That would be -3 plus 5 times 5, which is 25. So -3 plus 25 would give us a positive 22. So our result is a positive 22. Okay, now it's time for you to complete the questions on your Lab 1. This is on your handout, and If you have any difficulty with this worksheet or any of the other supplemental worksheets, please take the worksheets to our math lab along with your specific questions. The math lab locations and phone numbers are listed below. Good luck.